Good morning, all of you. I'm Dr. Anjan Kumar, working as an assistant professor in the Department of Mathematics, Basic Science and Humanities of BVRIT. I've been working here for past 4 years. Today, I would like to explain about the concept differentiation. So, before going to the topic, let me say the things whatever we are going to discuss today. First, let us go for under this differentiation. These are the things we are going to cover today. First thing, what do you mean by derivative? First thing is, what do you mean by derivative? Basic definition of differentiation. Next, I'll give you a few formulae. Finally, we'll do some problems. Now, let us go for the concept of derivative. So, first, our topic name is differentiation now. So, differentiation means the process of finding the derivatives. Okay, either it may be first order derivative or second order derivative, or it may be nth order derivative. So, let me repeat once again. Differentiation is nothing but the process of finding the derivatives. Now, I want to know what do you mean by derivative. So, to explain this one, let me take some simple example. Y is equal to x squared. We know that's a very simple equation, parabola equation. Y is equal to x squared. Next, I am restricting this x between 0 and 2. Now, let me think about the meaning of this y is equal to x square mathematically. Y is equal to x square is nothing but to get y value, I have to multiply x twice. That means y is equal to x into x. I can say same thing in other way as to get y value, I have to multiply x twice. So that means y is depending upon x. Whereas this x is not depending upon any other variable. Now that's why I can say that this y as a dependent variable and x as independent variable. Y is dependent and x is independent. Now, as per this example, x is restricted between 0 and 2. That means it's taking integer values 0 to 2. Now, the value of y is 0 when x is 0. That means if you substitute x is equal to 0 in y is equal to x squared, that means if I replace x with 0, I'll get y value as 0. Next, I'm going to substitute x is equal to 1 because already I told you x is taking the values between 0 and 2. Already I've taken x equal to 0. That's why I'm next substituting x is equal to 1. If you substitute x is equal to 1 here, 1 square is nothing but 1 again. So that's why y value is 1 when x is equal to 1. Next, let me take x is equal to 2. If you substitute x is equal to 2 in this equation, already y is equal to x square is there now. So if you replace x with 2, 2 square is nothing but 4. Next, I cannot take more values for x because x is restricting between 0 and 2. Now let me think about these y values. The values of y are not fixed. They are varying. Initially it is 0, then 1, then 4. That means there is a change in y. And this is happening due to the change in x. Now I can say this whole thing as there is a change in y with respect to x. I can call this one as derivative, and the representation will be dy by dx. I can read it as the change in y with respect to x. Now this is called first order derivative. Why we are calling it as a first order derivative means I am calculating the change in dependent variable y with respect to the independent variable x one and only once. So that's why I am calling it as a first order derivative. Next, and to go for second order derivative, the representation will be d square y by dx square, which is nothing but d by dx of dy by dx, means the first order derivative derivation, or I can say that the derivative of first order derivative, that is known as second order derivative. Similarly, third order d cube y by dx cube, I can write it as d by dx of d square y by dx square. Finally, nth order derivative d power n y by dx power n, I can write it as d by dx of d power n minus y by dx power n minus 1. Now this is called, all these are derivatives: first order derivative, second order derivative, third order derivative, and so on, nth order derivative. Okay, now the definition will be like this: the change in dependent variable with respect to independent variable is known as derivative, and the process of finding the derivative is known as differentiation. The process of finding the derivatives is known as, okay, as per definition it is okay, but how we can calculate or how we can find the derivatives? Okay, now first, how the derivative formula is came into exist, let me think about that one. To explain that one, let me take a function y is equal to f of x. Now what I am doing is, here I am representing the curve like this. So this is y is equal to f of x curve. Okay, and this curve is passing through the points P as well as Q. Okay, now the coordinates of P are x comma y I should write, but y is nothing but f of x. So thus I am writing f of x here. Next, terminal point is here some q, and not terminal point, I am taking some arbitrary point q here. Okay, now the coordinates of q I am taking like this. X coordinate I am taking x plus h. I am taking x coordinate as x plus h, and this y coordinate f of x plus h. Okay, next I am joining these 2 points by a secant line. Okay, now if I calculate the slope, then that will give the derivative. Actually, the steepness of the slope is known as simply derivative here. Let me calculate the slope here, that will give us simply the derivative. If you take these 2 points, next I am to calculate here m slope, which is nothing but dy by dx. Just now I told you. So that's why let me calculate that dy by dx value. Before that one, for my convenience, I'm taking this point as x naught and this point I'm taking as y naught, and this is x1, this is y1. Later I'll say about this h value. Okay, because the whole thing will run on that h value only. After deciding the h only, we can give the proper meaning to that derivative. Now we know very well that the slope is nothing but y1 minus y naught by x1 minus x naught. Now for this situation, y1 is nothing but f of x plus h minus y naught is nothing but f of x divided by x1 minus x naught. X1 is x plus h minus x naught is simply x. Next, this plus x minus x will become 0. Finally, I'll be having f of x plus h minus f of x divided by h. This is x only. Okay. So finally, you're left with f of x plus h minus f of x by h. Now without h, I cannot say anything here because I don't know h value here. Now this h is very small value. When this q is approaching to p, the h value will become very small. I can say that negligible, or I can say that that is traveling towards to 0, means approaching to 0. So that's why next what I'm doing is here, I'm going to write down this one, limit h tends to 0. F of x plus h minus f of x divided by h. So let me go back to a previous diagram. Okay. So if q approaches to p, okay, then how the change is carried forward in y value with respect to x. So that is known as derivative. So how this h will be very small, okay, and that will give us the derivative of the given function, which is nothing but slope here. Now already I have written here, limit h tends to 0, f of x plus h minus f of x divided by h. So the meaning of this one is, so if h value is how much small we will take, okay, that much fastly the above q point reaches to p. So now this is the actual definition of derivative. Generally we can call it as f dash of x, or we can say this as slope also. Limit h tends to 0, f of x plus h minus f of x divided by h. Now with this limit definition, with this definition of derivative, let me calculate the differentiation of x square. Find dy by dx of x square, and according to this formula, whatever we have learned in our intermediate, according to that one, d by dx of x power n is n into x power n minus 1, and d by dx of x square is 2 into x power 2 minus 1 is nothing but simply 2x. Now I have to prove d by dx of x square is equal to x by using this definition of differentiation. Okay. Let y is equal to x square, which is nothing but f of x. Now y dash, I can write it as f dash of x. Now according to this formula, first I should write limit h tends to 0. Now f of x is x square. But what I need to write here, f of x plus h, means wherever x is there, I should write x plus h. So x plus h whole square minus f of x is again this one, x square divided by h, that equal to limit h tends to 0, a plus b whole square is nothing but x square plus h square plus 2xh minus x square divided by h. Now this plus x square minus x square becomes 0. Next I will be having limit h tends to 0. X square will not be there. Simply I will be having h square plus 2xh divided by h. Limit h tends to 0. I am taking h common in the numerator. Simply I will be having h into 2x divided by h. Now this h and h will be cancelled. Next I will be having limit h tends to 0. Already h is cancelled, simply I will be having h plus 2x. h plus 2x. If h tends to 0 means h reaching to 0 means I can take it as 0.001 or 0.0001 like this. How small will take h? So that will give the justification to the definition. So if you write h is equal to 0 here or 0.001 or something else, very small value, finally be having 2x. So based on that formula only, based on the classical definition only, we are having different formulae for this differentiation. First let me go for power rule. So already I have written there, d by dx of x power n is equal to n into x power n minus 1. Next we are having some addition and subtraction rule. If you have two functions, addition or subtraction rule. So I am taking two functions u and v, both of them are functions of x only. Then d by dx of u plus r minus v is equal to du by dx plus r minus dv by dx. Next, multiplication rule. Let me go for multiplication rule. D by dx of uv is equal to u into dv by dx plus du by dx into v. Next, division rule or quotient rule. D by dx of u by v is equal to v square v into du by dx minus u into dv by dx. One important thing you have to remember, the v or function, v of x should not be equal to 0. Next, last one, some constant rule. So d by dx of any constant c, arbitrary constant, some function of v of x is equal to c into differentiation of v of x. That means I am writing this constant outside, and whatever the remaining term is there along with that c, I am going to differentiate it. Okay. Still now we have discussed about what you mean by derivative, how the formula came into exist, and we did one problem by using that definition of formula. Then I have given some basic differentiation rules of formulae. Next, let us do some problems based on this, based on the problems given here. For example, the problem is like this. If some y is equal to x power 6 minus 7x square then find dy by dx. Okay, first if any problem is given to us, we have to identify what is a dependent variable, what is a independent variable. If you see this problem which is given to us and is like this, y is equal to x power 6 minus 7x square. So it's very clear that y is a dependent variable and x is the independent variable. Always we have to differentiate with respect to independent variable. Dy by dx is equal to, so on right hand side I am having two terms. First one is x power 6, second one is 7 into x square. Next, d by dx of x power 6 minus, according to the constant rule, if any constant is there I should write that one outside, then whatever the remaining term is there I need to do the differentiation. Okay, next according to power rule, x power 6 differentiation is 6 into x power 5 minus 7 into differentiation of x square is 2x, because already I have written chain rule there. D by dx of x power n is equal to n into x power n minus 1. Now the answer will be 6x power 5 minus 14x. Now let me go for next problem. If y is equal to 2x minus 1 into 4x minus 3. Now if you see this problem, it's very clear that y is a dependent variable and x is the independent variable. We need to do the differentiation with respect to x only. But on the right hand side, it's not a single term, it's a product of two terms. So let me take the first term as some u of x and the second term as some v of x. Now dy by dx is equal to, so let me keep this u of x, which is nothing but 2x minus 1 as it is. Next, differentiation of 4x minus 3. According to formula, I need to write plus. Then I have to keep this 4x minus 3 as it is. I need to do the differentiation of 2x minus 1. Here 2x minus 1 will be as it is. Next, differentiation of this term 4x minus 1. So 4x differentiation is 4. Next, minus constant differentiation is 0. Next, here 4x minus 3 will be as it is. Next, differentiation of 2x minus 1 is simply 2, because 2x minus 2x differentiation is 2 and minus 1 differentiation is 0. So 2 minus 0 is nothing but 2. Finally, multiply 2x minus 1 with 4, 8x minus 4 plus 8x minus 6. So 16x minus 10. So let me take one more problem. D by dx of x plus x square by root x. So I am to calculate the first order derivative of x plus x square by root x. Now this is in the form of u by v. So I am taking this numerator as u of x and this denominator as v of x. Now d by dx of x plus x square by root x equal to, so let me revise that formula. D by dx of u by v is equal to, first denominator square, v into u dash minus u into v dash. Okay, now here v is root x, u is x plus x square. First, according to this formula, first let me write the denominator v square. V is nothing but root x whole square. Next, first I should write this v as it is, means root x as it is, and d by dx of differentiation of numerator, that is x plus x square. According to formula, minus. Next, x plus x square will be as it is. Next, differentiation of root x. I am writing this root x as it is. Now differentiation of x plus x square is 1 plus 2x minus x plus x square will be as it is, root x differentiation is 1 by 2 root x divided by the square and root will be cancelled. I'll be having only x, and if you simplify the terms, you're going to get like this: root x plus 2x root x minus x by 2 root x minus x square by 2 root x whole thing divided by x. 1 by x into root x plus 2 into, so this is x and root x is x power 1 by 2. So base are equal, powers must be added. According to that one, I'll get x power 3 by 2. Next, minus 1 by 2 into x power minus 1 by 2. I am bringing this root x. Root x is nothing but x power 1 by 2. And if you bring this x power 1 by 2 into numerator, it becomes x power minus 1 by 2. Similarly, 1 by 2 into x square into x power minus 1 by 2. So root x plus 2 into x power 3 by 2 minus 1 by 2 into, so x power 1, x power minus 1 by 2. Again, bases are equal, powers must be added. According to that one, we will get x power 1 by 2 is nothing but root x here, minus 1 by 2 into x power 2 minus 1 by 2. This is because bases are equal, powers must be added. So 4 minus 1 by 2 is 3 by 2. So this is the answer. So let me take one more problem. If capital A is equal to pi x square minus 20x, then find the rate of change in A with respect to x. So that means I need to calculate dA by dx value. dA by dx is equal to, anyway here pi is constant, that's why I am writing outside d by dx of x square, minus here 20 is constant, d by dx of x. So pi into, this is x square differentiation is 2x minus differentiation of x is 1, simply 20, 2 pi x minus 20. Okay, this is the solution for this one. Let me take one application oriented problem. Find the tangent of y is equal to x square plus x plus 1 when x is equal to 1. So here tangent is nothing but tangent line equation we need to calculate. Tangent line equation we need to calculate. So given equation is y is equal to x square plus x plus 1. So for my convenience, I am taking this as some equation 1. So first I need to calculate the tangent first, then I will go for tangent line. Tangent of this y at x is equal to 1. So tangent is nothing but I need to go for derivative of this y with respect to x. That means I need to calculate dy by dx. So differentiation of x square is 2x plus differentiation of x is 1, next plus differentiation of constant is 0. So finally I will be having dy by dx value. Now I can take it as m, which is nothing but slope. Okay, next I am trying to calculate dy by dx value at x equal to 1. That is dy by dx at x is equal to 1. Now wherever x is there, write down 1 here, 2 1s are 2 plus 1, 3. Okay, now this is slope value at x is equal to 1. Next, let me calculate the value of y at x equal to 1. That means let me calculate y1 value or y1 value by substituting x is equal to 1 in equation 1. then y at x equal to 1 equal to, so let me come back to the equation. So wherever x is there, I should write 1. So first 1 square 1, so this is plus 1 1 plus 1, so again I am getting 3 only here, so this value is also 3. What is asking us to find? We need to calculate tangent line equation, and tangent line equation is we know very well, which is nothing but, now the tangent line equation, now the tangent line equation is y minus y1 equal to m into x minus x1. So y I am writing as it is minus. So y1 means whatever the value I have calculated for y at x equal to 1, that is y1. So that is y1 value is 3. M, slope value just now we have calculated, so that is also 3. So let me calculate that value 3 here. Next, x minus, at what point is asking us to calculate as at what value of x according to the problem, that is x is equal to 1. So that's why I am substituting here x is equal to 1. So y minus 3 is equal to 3x minus 3. So y is equal to 3x. So this is the required tangent line equation. That means this particular tangent will touch this curve at the point x is equal to 1. So with this I am going to conclude. Thank you. Thank you one and all.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.